Hi everyone, in this video we are going to talk about how to solve problems in the dynamics of a particle moving in a straight line. Let's start with question 1. In this question, I and j represent the unit vectors in the east and north direction. To make it easier for you, let's identify the given information from the question. There are three forces acting on this particle. The first force is 3ai plus 4bj. The second force is 5bi plus 2aj. The third force is negative 15i, negative 18j. We are also given that the mass is 2 kilograms. Now, the first thing we need to do is find the value of A and B. From this question, we know that the particle is in equilibrium. This means the sum of all forces acting on the particle is equals to 0. To help us visualize this, let's draw the forces acting on the particle. The first force is 3A acting along the x-axis and B along the y-axis. The second force is 5B along the x-axis and 2A along the y-axis. The third force is negative 15i acting to the left on the x-axis and negative 18j acting downwards on the y-axis. Now, let's look at all the forces acting on the x-axis. Since the particle is in equilibrium, the total force to the right must equals the total force to the left. So the sum of forces on the x-axis is F1x plus F2x equals F3x. 3a plus 5b equals 15. We call this equation 1. Since the particle is in equilibrium, the total upward force must equals the total downward force. So the sum of forces on the y-axis is 2a plus 4b equals 18, and we call this equation 2. You can find the values of a and b using the elimination method. Now, let's eliminate a. Multiply the first equation by 2 and the second equation by 3, then you can eliminate a. And now we have found b, which is 12. Now let's find a. You can use either equation 1 or equation 2, it's up to you, but for now I will use equation 1. Substituting b equals 12, we get 3a plus 60 equals 15. So 3a equals 15 minus 60, which give us a equals negative 15. We have found a equals negative 15 and b equals negative 12. Now let's continue to part bi. If the third force is removed, work out the magnitude and direction of the resulting acceleration. First, let's copy the first diagram and remove the third force. The sum of forces acting on the x-axis is 15 Newton to the right. This is because when the object was in equilibrium, the total force acting to the right was 15 Newton and the total force to the left was also 15 Newton. Let's check again. The sum of forces acting on the x-axis is 3a plus 5b. When a equals negative 15 and b equals 12, we get negative 45 plus 60 equals 15 Newton. The same reasoning applies to the force acting on the y-axis. So the total force acting in the positive y direction is 18 Newton. The force acting on the particle is 15 Newton to the right and 18 Newton upwards, causing the particle to move diagonally to the right. Since the particle moves in the same direction as the force, we can determine the direction of acceleration using tan theta, which is the ratio of the total force upwards to the total force to the right. So theta equals 50.19. Next, let's find the magnitude of acceleration. To find the acceleration, we can use formula sum of force equals mass times acceleration. We already know that the sum of force is 15I plus 18J and the mass is 2 kilograms. So 15I plus 18J equals 2A. Dividing by 2, we get the acceleration A equals 7.5A plus 9J. This is the acceleration in vector form. To find the magnitude, we use the formula A equals square root of ax squared plus ay squared. Substituting the values and we get the final result. Next question. Find the distance traveled by the particle in the first 3 seconds of its motion. Let's identify the given information from the question. After removing the third force, the particle moves with constant acceleration. Remember, there are four formula for an object moving with constant acceleration. We need to choose the equation that includes t, a, u, and s. After choosing the correct formula, simply substitute the given value and you will find s. Question 2, Part A. In Part A, we need to explain a force diagram showing the force acting on the motorcycle. As we know from the question, the motorcycle has a mass of 200 kilograms and is moving along a straight path. The motor has a driving force of 1000 Newton and there is a friction force acting on it which is 600 Newton. You should remember that friction force always act in the opposite direction of an object's motion. So when the object moves forward, the friction force act backward. Part B. Calculate the acceleration of motorcycle. To find the acceleration of motorcycle, we can use the formula sum of force equals mass times acceleration. Since the forward force and friction act in opposite direction, we subtract the friction force from the forward force. 1000 minus 600 equals 200 A. So we get A equals 2 meter per second squared. Question number 3. First, let's identify the given information and draw the force diagram. A block with a mass of 0.8 kg is pushed with a force of 7 Newton on a rough horizontal surface. This means there is a frictional force acting between the object and the floor. However, from the question, we don't know how large the frictional force is. And the object has initial velocity u equals 2 meter per second and final velocity v equals 4 meter per second and displacement s equals 4.8 meter. Question A. Find the magnitude of the acceleration of the block. Can we use the equation sum of force equals mass times acceleration? Let's check. Sum of force equals pushing force minus friction force equals mass times acceleration. We already know the pushing force and the mass, but we don't know the frictional force or the acceleration. So we cannot use this formula. But don't worry, we can use one of the four kinematics formula. Let's choose the right equation that include V, U, A, and S. So we can solve for A. Now let's substitute all the values. We have 4 squared equals 2 squared times 2A times 4.8. And after calculating, we get A equals 1.25 meter per second squared. Part B. Find the magnitude of the frictional force between the block and the floor. From part A, we already know that acceleration A is 1.25 meter per second squared. So we can use the formula the sum of forces equals mass times acceleration. We already know that the mass is 0.8 kilograms since the pushing force and frictional force act in opposite directions. So pushing force minus friction force equals mass times acceleration. 7 minus friction equals 0.8 times 1.25. Next, 7 point friction equals 1 and 7 minus 1 equals friction, so friction force equals 6 Newton. Let's continue with part 2.